All right, taking a look now at graphing to solve our systems of linear equations. So we'll recap 7.1. We need to write a system of linear equations to model the situation. Tickets for the school play cost $8 for an adult and $5 for a student. The total revenue from one performance was $1,122, with 32 more students than adults in the audience. So let's say, let S represent the number of students, and let's say A represent the number of adults. Okay, so the school play costs $8 for an adult and $5 for a student, and they made a total of $1,122. So 8 times the number of adults attending plus $5 times the number of students attending equals 1,122, with 32 more students than adults in the audience. So there's more students, therefore students take away adults is equal to 32. All right, a couple other little reviews here. To find intercepts in order to graph. Remember, to find a y-intercept, we must let x equal 0 and then solve for y. To find an x-intercept, we let y equal 0. We'll sub that into our equation and then solve for x. So let's find the x and y-intercepts of x plus 4y equals 8. So the x-intercept, we need to let y equal 0. So x plus 4 times 0 equals 8. X plus 0, so x equals 8. Therefore, our coordinate for the x-intercept will be 8, 0. For our y-intercept, x equals 0. Therefore, 0 plus 4y equals 8. 4y equals 8. We divide by 4, and we get that y is equal to 2. So our coordinate here will be 0, 2. Okay, two equations in a linear system are graphed on the same grid. What are the equations of these lines, or graphs, if you will? And what are the coordinates of the point of the intersection? So let's look at the equations of the line. Remember, I'm going to look at y equals mx plus b. This is the quickest and easiest format to write an equation, in my opinion, if you can see the y-intercept. The y-intercept here for our red equation is 5. And the slope of this, we go up 1, rise 1, run 1. So the slope is 1 over 1, which is positive 1. So for our red graph, our equation is y equals m, which is 1. So x plus 5. For our blue equation here, our y-intercept is 1. And our rise over 1, so our slope, we go down 1, so negative 1 over 1, which is negative 1. So y equals negative x plus 1 is our equation here. What are the coordinates of the point of intersection of the two lines? Well, the point is here. So that will be at negative 2, 3. Negative 2, 3 are the coordinates. Explain why these coordinates are the solution of this system of equations. So this point is the only point that is true for both lines. So this line has a bunch, like a table of values we could totally fill out for every point on its line if we wanted. And we could do the same thing here. The only point that works for both, or is true for both systems, is where they intersect here. So again, this is the only coordinate that lies on both lines, or would be true if subbed into both equations. So for instance, if I put this coordinate into our equation, so let's say into this x plus 5, so 3 is equal to negative 2 plus 5. 3 is equal to 3. Well, that's true. Taking a look over here, y is equal to negative x plus 1. Well, 3 is equal to negative 2 plus 1. A negative is positive, so this will be positive 2 plus 1, which is 3. So this is true for both equations. No other point will work for this system. The solution of a linear system can be estimated by graphing both equations on the same grid. If the two lines intersect, the coordinates x, y of that point of intersection are the solution to this linear system. So our first step here is to graph these. So finding intercepts for both. All right. Let's look at this equation first. So let's find the y-intercept. This is where x equals 0. So 2 times 0 plus 3y equals 3. So 3y equals 3. Divide both sides by 3. We get that y equals 1. And we'll do the same thing for our x-intercept. This is where y equals 0. So 2x plus 3 times 0 equals 3. 2x equals 3. X equals 3 over 2. So our coordinates here were 0, 1. And 3 over 2, 0. So let's quickly graph those on our equations here. All right, I went ahead and labeled my axes. So we'll graph these 2 points. So we have 0, positive 1, and 3 over 2, which is 1.5 and 0. Now it's really important because we're using our graph to solve this or look for the intersection. It's very important that you draw with a ruler now. All right, so I've gone ahead and graphed my line, and I've used a ruler to draw a nice straight line between my 2 points. Remember, you could continue on in this fashion. It looks like it's down 1 over 1.5. So down 1 over 1.5 would put a point here, which we can also see is down 2 over 3. So down 2 over 3, and continue to fill in points if you're having a hard time drawing a really nice straight line. Okay, we're going to do the same thing. We're going to decide on the x and y-intercept for our other line. So x-intercept, y equals 0. So x minus 0 equals 4, x equals 4. So the point would be 4, 0. And for our y-intercept, x equals 0. So 0 minus y equals 4. Negative y equals positive 4. So we're going to divide both sides by negative 1 or multiply by negative 1. Doesn't matter, to get rid of the negative and get that y equals negative 4. Our point then is 0, negative 4. Plotting those, I get 0, negative 4 and 4, 0. And I'm going to draw a nice straight line through those. All right, after graphing both of my points, what we need to do is determine the coordinates that they intersect. So the coordinates seem to be here, and that would be at positive 3, negative 1. And we can go back and we could check that in our systems here if you really want to. That's how you can check your work. So 2 times 3 plus 3 times negative 1 equals 3. That's 6. Take away 3 equals 3, which is 3. That works. And then we have x minus y equals 4. So 3 take away negative 1 equals 4. Taking away negative 1 is like adding 1. 4 equals 4. That works. So solving back into your system's equations can help to double check your graphing. Jaden left her cabin on Something Lake in Saskatchewan and paddled her kayak towards her friend Tyrell's cabin at an average speed of 4 kilometers per hour. Tyrell started at his cabin at the same time and paddled at an average speed of 2.4 kilometers towards Jaden's cabin. The cabins are 6 kilometers apart. That was a lot of information where they just gave you the linear system anyways, where D is the distance in kilometers from Tyrell's cabin and T is the time in hours since both people began their journey. So graph the linear system above. Again, we're going to find the intercepts. Now, if you think about science, T is always on the X and D is always on the Y. And time and distance are always positive, so I'm going to draw a really large graph instead of just the one quadrant, if you will, of this graph. Okay, so I've decided that my time will be along the bottom here, again, because time is our independent variable and distance will be our dependent, so we'll put it along the y. And again, I'm going to ignore the cross in our axes here, and I'm going to graph this as a large graph. So let's find our intercepts. So we're going to find in this one, let's look at the d-intercept. That's where t equals 0. So d is equal to 6 minus 4 times 0. So d is equal to 6. Remember, our coordinates will be t and d. So our coordinate here will be 0, 6. Let's find the t-intercept as well. This is where d equals 0. So 0 is equal to 6 minus 4 times t. Let's add 4t to both sides. So we get 4t is equal to 6, divide both sides by 4. I get that t is equal to 3 over 2. So our coordinate here would be 3 over 2, 0. Same thing for our other equation. And we get the d-intercept here. So d is equal to 2.4 times 0. So d is equal to 0. Our coordinate is 0, 0. Now, if you note here, our t-intercept is when d equals 0. 0 is equal to 2.4t. Divide both sides by 2.4, and you get the same coordinate because t equals 0. Now, that's not helpful. We need two coordinates to plot a graph. So let's make a quick little table of values. So let's do t and d, and we'll do t of 0, 1, and 2. So if t is 0, we did this already, d is 0. If t is 1, we get d equals 2.4 times 1, which is 2.4. For t equals 2, I'm multiplying by 2, and you could continue if you'd like. So let's label our axes. I have 1, 2, 3, 4, 5, 6, and let's make our distance go up to 6 as well. So 1, 2, 3, 4, 5, and 6. All right, plotting our coordinates. We have 0 and 6, and 3 over 2, so 1.5 and 0. And then we also want to draw our nice straight line. Okay, graphing our other line, we get 0, 0, 1, and 2.4, which appears to be like here. And then 2 and 4.8, which is like here maybe. Drawing a nice straight line. Okay, so we need to find the intersection point. And what it looks to be is right at x equals, or I guess t equals 1. So the coordinate was a plot we actually plotted here. So 1 and 2.4 appears to be our coordinate. Now 1 represents the time, so t equals 1 and d equals 2.4 is where they intersect. So they meet 2.4 kilometers in from their journey, and they meet 1 hour after they began their journey from that coordinate. All right, last example here. Write a linear system to model this situation. Wayne received and sent 60 text messages on his cell phone in one weekend. He sent 10 more messages than he received. So let's say let R represent the number of messages received, and let S represent the number of messages sent. So he received and sent 60 text messages. So sent plus received equals 60. He sent 10 more messages than he received. So he sent 10 more, that's a greater number. So S minus R equals 10. Graph the linear system, then solve the problem. So we need to find the intercepts here. So what I did is I moved each of these into a y equals mx plus b format. So s plus r equals 60. Let's just let s be our y and r be our x values. So y equals mx plus b is our format that we want to look at. So we're going to say s equals mr plus b is what we're looking at. So s by itself. Okay, so we're going to subtract r from both sides, and we get that s is equal to negative r plus 60. For our other one, we have s minus r equals 10. We need to add r to both sides, so we get s is equal to r plus 10. Again, we're using just a positive axis, so I have redone my graph to be like a whole thing, and I've forgotten about the division of like the quadrants here. Okay, we need to have our axes labeled here. So I labeled mine in 10, so 10, 20, 30, 40, 50, and 60. Same thing upwards. And 0. Okay, so graphing our line here, s minus equals minus r plus 60. So our s-intercept or our y-intercept is 60, and our slope, is negative. So we're going to go down 1 over 1, down 1 over 1, down 1 over 1. Alternatively, if you don't like this, go back and find your s and r intercepts and then just plot those two. All right, so I've plotted that one, and then we're going to go and our other one starts at 10, and again, it's a positive slope, so up 1 over 1, or you could say up 5 over 5, up 5 over 5, up 10 over 10, whatever it is, and plot that line. All right, I've graphed both lines, and you can easily see that they intersect at this point here, and that point seems to be 25, 35, and remember, this is our S. So that means that Wayne sent 35 messages and he received 25 messages over one weekend. Again, if you'd like to double check your work, go ahead and sub back into our original equations, and they should hold true.